I guess sorry for the technical issue. Now we can start today's lab session. And I just want to introduce myself first. My name is Wei, and I'm the TA of this course. Um, I think you can find my email address in the Toledo, but in case you want to get in touch with me, um, my email address is at a11 the so this is um my office number. It's on the fifth floor of this building, so if you wanna pass by, feel free. Okay, now we can have a recap of the last lecture, where we have learned how to do the inference with the lasso. And in this lecture, there are two main cases. The first one is if you have a low-dimensional covariance. In your model, that means you only have several covariates to use. And another case is you have many covariates to use. Let's say it's in theory it may grow to infinity. And so we can talk about first only case one. In the case you have a very small number of the covariates. So we are interested in a causal problem. We want to learn the causal effect on the education, on the earnings. Let's first pose a linear causal model. So the key assumption of this causal model is to say there is no correlation between the education and the error term, also for this experience. So there is no remaining terms in the error term which is correlated with the variance that can affect the outcomes. It's a key assumption to get a causal effect of these beta 1 and the beta 2. And with this model, we can simply estimate the beta 1, and then this estimated beta 1 will give you a causal interpretation on what is the effect of the education of earnings. So in practice, we want to test if this effect is positive or negative, or it is zero. Then how can we do it? So basically, in practice, you can get a data set, right? And based on this data set, you can get an estimate of the beta 1, but you only have one beta 1. It's an estimated beta 1. Let's say if we have many independent data sets, you can get many estimated beta 1, right? Then you can get a distribution of the beta 1, which is we say it's asymptotic normal. And based on this normal distribution, we can perform the statistics test. Let's say in practice, the data set you get, and you get an estimate, which is quite large, maybe lies in this area. Then you are confident to reject this null hypothesis. The null hypothesis is to say that the causal effect is zero. But for now, the estimate you get is very large, lies in this area. So you have some confidence level to say, oh, I can reject this null hypothesis, right? You can say the education do have some effect on these earnings. And this is a case with low dimensional covariance. What happens if you have many covariates? Then you can't apply the OLS anymore. You can use another technique, which we call it as lasso. But the simple use of lasso will give you a biased estimate. So the idea is to use these two methods. One is called double selection, and another one is called double machine learning to perform the inference of the parameter with many covariates. They are basically these two methods. And these two methods are asymptotically equivalent. So the idea of the double selection is to say, you select some covariates, then you run the regressions on this set of the covariates. And the idea of the double machine learning is to say, and you regress several error terms. So basically, I think it's the same, and in the practice, yeah, you can choose both. Also, in this question set, we will ask you to perform double selection and double machine learning. Then you will compare the difference between these two methods. Okay, so I will just jump to this empirical data set. So let's say we are interested in to learn the causal effect of the gender on the wage, and we have many other control variables. Let's say full-time work, age, some quite a lot of controls. And in this case, OLS is not suitable for this case because you have many X here, right? So you have to use double selection or double machine learning. I will jump this procedure direct to this coding part. To perform the double selection or double machine learning, we need a package called HDM. And normally this procedure is to first you define your covariate matrix X, and in this case, it is called controls. So you first define what are the controls. We have many controls. And what's your outcome? In this data set, outcome is the wage, the hourly wage, and what's your treatment? So the treatment means what's your covariate of interest, okay? And the D is the gender. And then you perform this double selection by using this function, Lasso effect. This will be used in the next question set, and then you can summary this model to get this result, and it returns the estimate is around minus 0.3, and the significance level is about 0.1%, so it's quite significant, right? So we can conclude here that the gender does have some effect on the hourly wage. And this is the idea of the double machine learning. I will jump this detail to the how to perform the double machine learning in the RStudio. Still the R-Lasso effect function, but you have to specify the method equals to partitioning out. So for the double selection, the default method is double selection. So you don't need to specify anything for this function. But for double machine learning, you need to say it's partitioning out. Is it clear? And I can also get an estimate from the double machine learning, right? This estimate is quite similar, and the confidence level, the significance level, also the 0.1% significance level, so almost the same, the estimate from the two methods. And the last part is about, so in the causal model, as I said, the key assumption is you need to assume these covariates is uncorrelated with error terms. So that means the covariates need to be exogenous. But in practice, so let's say in this data set, there may be some intrinsic ability which can affect both education and your earnings, right? Some intrinsic abilities, but you can't observe. So we would argue that in this model, the education is not exogenous. Then the estimate of beta 1 will not have a causal effect anymore. What's the solution to this kind of problem? And we're gonna use this instrument variable. And what's the idea between the instrument variable is that we have to find another covariance which satisfies these three conditions. And I'd like to emphasize these three conditions are very important. We will definitely have a question in final exam to ask you if the instrument variable can satisfy these three conditions. So the first one is called exogenative. That means this instrument variable is uncorrelated with the error terms. And the second one is to say we need this instrument variable to be correlated with the treatment, the covariance you are interested in. And the last one is to say the instrument can only affect the outcome through the treatment. So you really need to keep these three conditions in mind. Let's have the example. So in this case, we want to learn the causal effect of education on the earnings. And as I said, there may be some unobserved terms which is related to the ability, which can affect the earnings and also correlated with education. So in this case, in this example, we choose the college proximity at a specific age as an instrument variable. So we can verify these three conditions. First, it's not correlated with error terms. So basically, the physical distance, I can see it is not correlated with ability, right? It's just your location and the distance between between your home and your college. So I believe this exogenity condition, it can be satisfied. Then we can move on to the second condition, relevance. Can we say the proximity is correlated with the education? So let's say in the case you live very nearby a college, so you somehow have a higher chance to go to the college, right? That's my explanation, and everyone has their own explanation. So, also in the final exam, it doesn't matter you give a correct explanation because there is no correct explanation of these three conditions. You have to give a reasonable explanation, and it's enough in the final exam. The last one is exclusion. So this distance between a college can only affect your earnings in the future through education, right? It's quite easy to understand this condition. So it's just an example to illustrate why this proximity is a valid instrument variable in this model. And for the two-stage least square, I will just jump on these details. And what happens if you have many covariates? So in that case, you need the last law, but you still need a instrument variable. So it's a combination of instrument variable and last law. Yes, we can have a look at this example. So in this data set, people want to study the causal effect of the institution on the GDP growth in the colonized country. And they have many controls, including the latitude, I think, including the latitude. And in this example, the IV they used is the settler mortality, so the death rate of the settler. And we also have to verify the three conditions of this instrument variable. So the first one is exogenous. So I think the death rate, because the settlers only stay in the colonized country in a specific period, right? So if you have already controlled the latitude of the country, I think it's the main fact which can affect the death rate. If you have already controlled this latitude in your model, I would say this death rate is exogenous. And the second condition is correlated with the institution. It's also so the reason is if the death rate in the colonized country is very high, that means you don't want to stay in this country for a long time, right? If you don't want to stay for a long time, you will try your best to extract the resources from the colonized country. So that can affect the protection from the expropriation, right? Is it clear? Okay. And the last one is, the death rate can only affect the GDP growth through these institutions, right? It cannot affect the GDP directly. So that's the explanation of these IV. And this is estimation result. We can jump these results. Same as before, you can either use double selection with the IV or double machine learning with the IV, also two methods. I will jump the idea of the double machine learning. So the last case is what happens with IV when the instrument variables is also high dimensional. So that means you have to also select among these many instrument variables by using the lasso. And in this case, the data example is the effect of the taking loss on the let's say on your house price, and the IV chose in this data set is the demographic characteristics of the judge. So there are many characteristics of the person, and in this case you need the double machine learning or double selection in this case. Also select the control covariates and the instrument variables. Also, I will jump these details. So let me summarize what we have learned in the last lecture. So two main cases: low dimensional covariates and high dimensional covariates. If you only have low dimensional covariate, you just use OLS. If you have many covariates, you need to use double selection or double machine learning. Another case is about the instrument variable. So if you suspect that your model, let's say this model, the covariate is endogenous, then you need the instrument variable, and you have to find a valid instrument variable, and then run the two-stage least square to get a valid estimate. And another case is that you have a low dimensional IV, but you have many covariates. So you have to use double machine learning and double selection. But the last case is if you have many instrument variables and also many covariates, still use the double machine learning and the double selection. Okay.
It's not really connected to I guess machine learning part, but I was just wondering about this last example where we have those expropriation laws. So how does it work that we have one variable that is so we have one variable which is like protection from expropriation, and this is endogenous, right? And then we are using instrument,
yes,
like many instruments for that.
In this case, only one. Yeah.
Oh no, sorry, I meant the other one, the one with the latter one. Yeah, this one exactly.
Yeah.
So we have one endogenous variable,
yeah,
and then we are using several instrument variables,
yeah,
as instruments for this one variable. So how does that work? Are we like averaging out over like how can we use several instruments for two instruments for one single variable?
I mean, you mean in the estimation or in the...
Yeah, just in the estimation, because you have one endogenous variable and then many demographic characteristics. So
okay, let's take an example with I think we say double selection. Yeah, I would use so the step is you only have one control variable and you have two regressions. The first one is you regress. So you see the control, you treat the control variable at the outcome. So you run the treatment on these for these many instrument variables and many controls.
Yeah, I get it. I was just asking about the case with high-dimensional controls. So like not so the later one. So the one with like those house setting laws. You know the last one.
This is the last one.
Uh,
This data.
oh,
This
okay.
example.
So how? So I still don't get it. Like, how can we use several instruments to instrument for a single endogenous
So
variable?
if you have one instrument, the two-stage regression, the second stage is to regress the treatment on the single instrument variable and plus these covariates, right?
Uh-huh.
If you have many instruments, it's still the same, but you run the Lasso regression. So still the outcome is the treatment variable, and you regress it on many instrument variables plus many covariates. But you use the Lasso instead of use the OS.
So then the other, like all the others, instrumental variables are treated like covariates in
Yeah,
Lasso?
indeed. In this case, the case is you have many controls and you have many instrument variables. By using Lasso, the idea is to select a few of them.
Okay.
Okay. Also, when you have many instruments variables, you have to select a few of them. Okay.
Okay, thank you.
For the final regression. So the idea of the Lasso is to say maybe only a few of these covariates matter to the outcome. We have to select them out of these many covariates. This is the idea of Lasso. Is it okay?
In causal, which is trying to see prediction,
Yeah.
is it also visible, I suppose?
I think if you are only interested in the prediction, I think there is no like treatment variable you want to include as more as covariates you can to get a good prediction result. So the prediction and the causal effect is two different problems. For the prediction, you want many covariates to get a very accurate prediction, right? It doesn't matter which one is really matter to the outcome. You want is kind of like the average of these many the average of these many covariates to give you a good prediction. But in the causal effect, we really want to learn what's the effect of, for example, of the education on the earnings. So it's a specific covariate in the causal effect. But for the prediction, it doesn't matter.
It also means
Yeah, we don't need the two states. We don't need the double machine. Yeah, we don't need this. Yeah. Basically, you run a Lasso, and you separate the data and in the training and test the data set, and you run the Lasso in the train set, get your estimate, and then you validate your prediction in these test sets to see if you can have a good prediction result. So yeah, it's different from this setting. Yeah. Any other?
Or how do you know how many instruments it's going to be one or
Yeah, that's the case. So that is also the same case for the controls. How many controls you want to do in your data set? So I think in practice, a safe way is to collect all the instrument variables you can have, and you let the Lasso to select. You see what I mean? Yeah, I think it's a safe way in practice. Any other questions? If not, we can move on to the tutorial. The second tutorial. You can find it in the Toledo. I think. Yeah. So in this problem set, we wanna study the effect of the participation of a saving plan on the let's say the wealth of the household. So We just want to learn whether you attend this plan will affect your net asset or your will. And in this data set, we will use these following controls: your age, if you have a DB pension, your education, your family size, and some controls. And the treatment variable is, I think in this data set is called P401. Yes, it's P401. It's your treatment variable. So if you participate in this plan or not, it's a dummy variable. And I will give you maybe half an hour to finish the first exercise, and then I will go through together with you. Before that, I wanna, so you can first look at this screen. Yeah, maybe it's a bit too small. Can you see this function? This one, lasso effect, this function. This is used in the exercise 1. So for now, you only need to focus on this lasso effect function for the exercise 1. If you don't know how to use this function in RStudio, you can help the name of the function, and you will have the explanation at the right corner. You need to rename one of the people. Rename of the tree variable. So if you want the name is you want later.
Okay, but how would I rename this?
L. I would say
What's in the data set?
well, in the data set, it's we define these matrix, these core vector. I will treat them as a data drive. APT. Yep.
Okay,
That's
I will search for it.
yeah, but definitely the return estimate return the estimate is for the D. Okay, where you lose it.
Okay.
Everyone, the side one. Yes, then we can go together. So let's first have a look at this first question. The first one is to install and load a package, which is called HDM. So normally, if you don't have this package in your studio, you use this command, install packages, and then you put the name of your package, let's say HDM or maybe some other names to install this package. Once you have installed the package, you have to load this package by using library. So the library, the name of the package, then you can use this package. Also, the pension, this dataset, the pension dataset is included in this package. To apply to, or to use this dataset, you just have to data pension, and you will see so from the beginning. Let me clear the environment. You library the package and you data pension. Oh. You will have a pension in your environment, right? In the right corner, you will see a data set named as pension. And the second question is to use the function ALASO effect to perform the double selection to obtain the estimate of the participation of the plan of the household net asset. So we have to use these following controls, and we have to first define them at the matrix. So let's first define the outcome. The outcome is the net worth of the household. So we say Y. Normally we use Y to define the outcome, and Y equals to this guy. And what is the treatment? So the treatment is the participation of this plan. So we set a simple, use this capital D as a normal simple for the treatment. And D equals to this guy. And then we have to define what are the controls. And the X is this guy. The age, we include the age, the DB pension, and etc. from this pension data. And then we can run the double selection. So let me show you X. Normally the 0 means there is no intercept. If I don't have 0, I have an intercept, right? You see? So with 0, no intercept in the controls, you put a 0. Okay. Once you have X, D, and Y, you can perform the double selection by using this function. So let's say if in the exam you forget how to use the function, you can basically help. But you have access to all the materials during the exam, so no worry about this issue. you can also have access to these code solutions and everything. Okay. So with this help function, we can see how to we can see the usage of this function, and this is called rlasso effects. But basically the same. You can use rlasso effects or use the rlasso effect. It's the same. And the first argument is specified as the control matrix, so it's our x. The second argument is the outcome, and the third argument is the treatment variable. You have to follow this order. So the first argument is only for the control matrix. The second argument is only for the outcome, and the third argument is only for the treatment. You can't exchange the order. Let's say if you put D in the second but Y in the third, I think it will give you a wrong estimate. So make sure you follow the order. Is this clear? Okay, great. So then the question is the treatment effect significant? Then we have to look at the significance level of these estimates. So we say a DS1 is this model, and we summary this DS1, and sorry. As DS1. You summarize the DS1 and you get your estimate of the treatment variable, which is around 10,000, around 10,000. And this gives you your significance level with 3 stars, and it's 1%. 1.1% significance level, so it's quite significant, right? Okay. Then the last question is to perform the double machine learning. The only difference between the double selection and the double machine learning is that you have to specify the method equals to partitioning out. So the partitioning out is for double machine learning. And the same function, same place for these x, y, d, that you specify method is partitioning out. And you get an estimate from double machine learning. We can see the estimate of the coefficient is quite similar, and we have the same significance level, right? So it also illustrates that the difference between the two methods is quite tiny. So you can choose either method in practice. Another thing I want to mention is that, some people may be annoyed by following the order of these arguments. You can also use this one. So let's say in the case if I don't want to follow the order of the arguments, so I can say y equals to y, give the name of the argument, and I want to follow the d, the treatment equals to d, and x equals to x, and it will give you the same estimate. Is this clear to everyone? Okay, if you don't want to follow the order of the arguments, you have to specify the name for the arguments, okay? Then the next question is we want to add more control variables into the model because we may suspect these covariates are not exogenous because only a few covariates in the model, so we want to add more controls by adding the polynomials of the controls, or you add the interaction between these controls, and by using these command, we can get more controls. And then we see how many controls do we have now. If we don't interact the higher order of the controls, the dimension of the X, we only have 10 controls. But let's say if we have add higher orders of the controls, then we get 88 controls in the model. Now we can run this double selection again to see if the estimate changes a lot or not. It doesn't change too much, right? Let's look at the DS1. So the significance level doesn't change, also 0.1% significant. And the estimate changed a bit, but not too much. Then we can run this double machine learning with these many controls to see what happens. The same. The estimate changes a bit, but not too much, and remains the same significance level. And the last one is we add the 3 orders of these control variables to see if there is changes happening. The same, we define the control matrix with these 3rd orders. And we can check the dimension of the covariates. For this control matrix, we have around 500 controls. It's quite a lot. And again, we run the double selection to get the estimate. It takes a bit time. Yeah, still, the significance level remains the same, and the estimate, quite close to the 2nd order of the control matrix. Yeah, very similar. So that means in this case, it doesn't help a lot by adding more and more controls. So it's enough to just use these controls. It will not give you a different estimate. And same, we can check what the double machine learning returns. Yeah, for now, do you have any conclusion for the exercise 1? So our finding is that by adding more and more controls, the estimate does not change a lot. So if you suspect your covariate is endogenous, and by adding more and more controls, it doesn't solve this problem, right? Because the estimate does not change. So if you suspect the covariate is still endogenous, you have to come up with another solution, which is instrument variable. And we will see if the instrument variable will give you a different estimate from this exercise 1. This double machine learning, give you almost the same estimate. So now we can move on to the exercise 1 to see if the IV can give you a different aspect or not. The function you have to use in the exercise 1 is called R-lasso IV. And the usage is similar as the R-lasso effect. You have to specify outcome, control variables, treatment variables, plus a instrument variable. I'll give you also 30 minutes to finish the second exercise. So the idea of these question set is to so the exercise one is to evaluate by adding more and more controls if there is a change in the estimate, and the second exercise is to see if the add of the instruments variables will give you a different estimate.
What is the origin of the Olympics actually? So because the original one was participation of Greek for 1 year.
Yeah.
So um yeah, I guess it could be like a legend and could be affected by that some humans are more definitely popular and Latin American forms. Maybe there's
Yeah.
more players also participate.
If they wanna, yeah, some people will choose, they choose a firm, like
Yeah.
the firm's catalyst. Like,
Yeah,
there's a substance sometimes which can correlate with the participation, which can affect your map assessment. Right? You see what I mean?
yeah.
That's is somehow maybe indulgent.
I don't recall the particular
Because people choose the firm, they choose the firm fine. If the firm has the least one for one.
Yeah, but if your digitalization will done, it means your company also.
Yeah, it's true. It's true. So with this at ability, so you can really sort of here is those
Yeah.
that it's I mean yeah, you people to have but in uh if they didn't want it, I wanted to say this it could be important. This I think that's people use this because if your personal information is yeah, yeah, absolutely.
Which is
Yeah, okay.
but
The algorithm represents as a sort of movie for the movie after the nation scenarios that it's changing. You can understand the area of the song is the eye. Because that would have to be a different. So you put some food in the form that it's put in the why. I think it's the plan.
Okay. So this is because my Lord Sheen controls have different incidents to and it would be students example will reflect high-dimensional finite patterns. Well, something like personal information, it would be aware of the situation. Impact, well, not very good. But
I think everyone has finished it. You can think about why the first question of the exercise two. So you have one treatment and you have first order of the controls, right? And once you include the IV, the estimate will be different from the case without IV. You can think about why this happens. And another thing is just give you an example of how to in the final exam how to explain or how to verify the three IV conditions. But normally, I think it's better to always give a specific example of why it satisfies this condition or why not. And I want to emphasize that for these three conditions, especially the endogenous, I think, yeah, it's really arguable in practice. So as long as you can give a reasonable explanation, it's fine in the final exam. There is in the history no, I think it's different on the local segment. Um, local segment that time while one without the it's a really tricky with this, right? Yeah. And can see patients by one. I think not because the population like we thinking yeah, you do the forecast impact to it's not anything only it's not local treatment. Low attitude.
2 weeks.
Yeah,
Okay.
I think so.
Good.
I want to come back to so I'll check with them.
Okay, but
I think it's not good positive. But you're right. Because I use somehow it's average because it's a time killer. In the case you have continuous treatment therapy, it would be really effective. But
that's good.
and then they go, because where people is true, that's all people to they yeah, always been everything that was all men. It's just like that. And it does the best. Well, it was right. And because like when I walk down there, I have that. It was walk it. Anyone else seems to be.
Yeah.
And doesn't do very well for control variables.
Yeah, all big names.
I think that's what was the next week, and it's the next case. The people is always just. Everyone, yeah, I think everyone has finished. Let's go through the exercise 2. Yeah. So the first question, it's a very, very common one. Do you think it's a good instrument variable? Is it correlated with the participation of the plan? I mean, definitely, right? If you are eligible, you tend to participate in the plan, somehow correlated. And does it affect your net asset only through the participation? And I think it's yes. You have the eligibility, but you don't participate in the plan, it won't affect your will, right? And the last condition, I think, is the most tricky one. Do you think it's correlated with the error time or the eligibility? Yeah, who think it's exogenous? Do anyone who think it's uncorrelated with the error times? With some like propensity to save money? Everyone think it's arguable. This one? Yeah. So, cause yeah, when you choose a job, if you have the tendency to save the money, when you choose the job, you may select the firms which can propose this plan, right? Then it can somehow affect your pension after you retire. So it's really arguable for this exogenous condition. Is this clear to everyone? Why somehow it is correlated with some error terms, let's say your tendency to save the money, you don't observe people's tendency to save the money, right? It remains in the error term, but you tend to save money. When you choose your job, you may select the firms who can provide this plan, right? That means the firm which can provide this plan, that means you have the eligibility to this plan, right? Okay, is it clear to everyone?
The question whether it only influences the net assets through the pension plan, the patient participation plan. Could we also then not say that it also influences it to the fact that you would be more likely to save money and thus that you have higher net assets?
Yeah, that it can be seen as the endogenous distribution. If you say it's endogenous, then this eligibility affects this tendency to save the money, then affects the net asset. So the exclusion is to say if you believe it's endogenous, then the revolution condition will not be satisfied anymore, right?
So when you think it's endogenous, it's not the exclusion will never be satisfied.
Yeah, I think so.
Yeah, but actually, I think it could affect the net assets outside of participation, because if someone is really focused on saving,
Yeah,
then he might be enrolled in 401k, but then also he might save more outside
yeah,
of this pension saving.
yeah.
So it's possible that if he's eligible, then he will also have higher savings outside of this 401k. Right?
It's true. Yeah. This example, I don't really like this example. I think the example we talked about the college proximity at a specific age, and this idea, I think it's much better than this case. So for this case, I do agree with you that yeah, you can't say too much about the validation of the ID. I agree with you. Yeah, but the idea of why we come up with this exercise is to say yeah, give a reasonable assumption, because this one is adopted by some researchers, and yeah, that's yeah. But I think in the final exam, we will give you a good example that you can explain the conditions easily. Okay. And then reproduce the questions to the second and third and the last questions in the exercise 1. So we do the same, except we have to define the instrument variable, and we set it's a z, and we first only include the first order of the controls, only the x, and then we will see the estimate. And we can have a look back at without the ID. What is the estimate? And you can see the estimate is, I mean, not very much, but a moderate difference between the estimates, right? So let's say in the model you have only first order of the control. It gives you an estimate which differs from the one you include the ID. That means what? I could say without the ID, only with the first order of the controls, the treatment variable is maybe still endogenous, right? Because the ID gives you a different estimate. If the ID can give you a same or similar estimate, that suggests with the first order of the controls, the treatment variables is already exogenous. Is this clear to everyone? Okay, that's why the ID give you a different average. So in practice, let's say in practice, you don't know exactly how many controls you have to include in the model to make the covariance to be exogenous. You can verify it by finding a instrument variable to see if the two methods will give you a similar or different estimate. Now we can move on to the model with second order of the covariance of the controls to see if it give a similar estimate or a different estimate. Now we can see that after including the second order of the controls, it gives an estimate which is similar with the one including the ID. So that's how some suggest that ID, the ID may not be needed in this case because the second order of the controls is enough to control the exogenity. That's why the two gives a similar estimate. It is clear to everyone.
Could we also have concluded the same thing just out of the first exercise because the second and third one are
doesn't change. Yeah, doesn't change anymore. But yeah, but it's always better to verify the ID can give you a different estimate because yeah, the controls you included in the model is always finite, right? Even it's very large, it's still fine. It's always better to find a valid ID to see if the estimates are different. Then we move on to the last estimate, and I expect the estimates are similar. So yeah. Yeah, it's always a trade-off between the let's say in practice, it's always a trade-off between the running time. So it's always better to include more and more controls in the model, right? But you sacrifice the running time of the model, as you can see. So it's always a trade-off between these two issues. And yeah, they give the same estimates. And also with the third order of the controls, the estimate is very similar with the model including second order. Okay? But that's how some suggest that in this case, it's not enough to. Oh no! In this case, it's enough to only include the second order of the controls, and you don't have to use the ID. Yes.
It depends on the different result using the ID method only to define the more controls. You can say we have
Uh,
I can see a difference between
yeah, the thing is to add more controls, but also to use ID to see include and not include ID to see if there was any difference between the two. Okay, it is clear.
So in this case, I view this first set of controls was still probably endogenous.
Without ID, yeah, without ID, it's without ID because with ID, including the first order of the controls, with ID and without ID, the estimate is different, right?
Yeah.
And that suggests that the model without ID is still endogenous because the use of ID is still solved in endogenous form. But you don't know with this ID and the first order of controls is enough to control the heterogeneity or to make the variance to be exogenous. So you need to include more controls to see if anything changes. Okay, it is clear to everyone. So let me so in practice, I mean, in practice, the best thing is to find a valid IV and including more and more controls in the model. But as I said, you sacrifice the running time of the model, and you will spend time to find the IV, you will spend time to collect these many controls. It's always a trade-off in how many you have to include, how many controls you have to include in the model. Yeah, I think it's an idea. Yes. Yeah, it's also another solution. Yeah. The question is how can you say it's a better idea than this one? Yeah, you're gonna try, right? You're gonna find you think this is a better idea, then you have to run this before to find if there is difference between the aspects. If there is, maybe it suggests that this one is better because it's different. But there are many factors which can affect these endogenous problem. So yeah.
Sorry, my question is like if you take away that model, would the only logic the necessary?
Yeah.
Or don't know for sure.
We don't know for sure in practice. That's an ideal. It would be more and more to check.
And once you be more against the hierarchy of factors, then it would take filters, or we could say still.
I think for okay. That's the change.
So just to make sure, you will add more controls so that your IV becomes more exogenous.
Yeah.
Yeah.
More controls your IV. I mean, the idea of IV at the very beginning, idea of IV is that you don't have that many controls, right? I mean, let's say if you can include all the factors which can affect the outcome, you don't need the IV, right? But the thing is, yeah, you can't find all of them, right? Yeah.
So in this case, we're just like adding more covariates until the estimate doesn't change, and then if it doesn't change, it means that we probably have enough, I guess.
Yeah. It's my solution for this. I will stop after the second order of the controls. After running the third order for controls, and I find no significant difference between the estimate, and I think I will run with a smaller model on the second order of the control. It's my opinion.
But this is like specifically with lasso because then you just use like cut off or like make zero those variables that we don't need those covariates, right?
Yeah, it's true.
So
Yeah, with the last also, yeah. It's also one point. Including more and more, and the estimate doesn't change a lot. That means Lasso doesn't select these additional covariates. It will give you the zero estimate coefficients of these additional controls. Anyone has other questions? So today's lab session, I think it's an easy one. It's a simple one. And I think what you have to master is the two functions, the usage of the two functions, Alaso effect and Alaso IV. And I think the most important part is to verify the three conditions of IV. That is a must be mastered question in the final exam. Yeah.
Yep.